Hi everyone, myself I am Ramesh T from Cambridge Institute of Technology. Today's my topic is hypothesis testing of a sampling distribution for single mean. In this session, I would like to explain in detail how to solve the problems on testing of hypothesis for a single mean by considering one or two simple examples. Now let us consider the first example. In lifetime sample of 100% light bulbs produced by a company computed to be 1570 hours with a standard deviation of 120 hours. If mu is the lifetime of all the bulbs produced by the company, test the hypothesis for mu is 1600 hours. Against the alternate hypothesis, mu is not equal to 1600 hours using the level of significance 0.1. That is, in this problem, we need to test the hypothesis at 1% of significance. Now, data we have of the sample that is given. Here, the lifetime of sample that is a lifetime of a sample 100 that is called here size of the sample. So we need to test the hypothesis for this sample that we have size of the sample divided by small n that is equal to 100. Next, mean of the sample is also given. Here, mean lifetime of bulb is given, that is 1570 hours. That is normally denoted by X. And one more data, standard deviation of bulb is also given, that is 120 hours. In this problem, we need to test the hypothesis for the mean population. Mean population mu is equal to 1600 hours. You see, first, we need to assume the null hypothesis, that is normally denoted by H naught. Here, the mean population is always the null hypothesis, that is mu is equal to 1600 hours. Here, alternate, you need to consider an alternate hypothesis that is normally denoted by H1. Here, H1 is always against to H naught. That means here H naught is mu equals 1600. So H1 is mu is not equal to 1600 hours. Now by using all the given data, we need to compute the standard normal variate Z by using this standard formula that is given by Z is equal to x bar minus mu divided by sigma by root n. Now let us substitute all. What is x bar? That is 1570 hours mean of the sample minus what is mu? That is mean of the population, that is 1600. What is sigma? Standard deviation of the population, that is 120 hours, and the square root. What is n? Size of the sample, that is 100. Now let us substitute all and simplify. We get z is equal to minus 2.5. That means in this problem, our calculated value of z is equal to minus 2.5. But already we know that at 1% level of significance, z lies between minus 2.58 to plus 2.58. But here, z calculated value is minus 2.5. That lies between minus 2.58 to plus 2.58. That means our assumed hypothesis H naught is accepted. Suppose if z lies outside the interval, in that case we need to reject the hypothesis. But here our calculated z lies within the given interval, hence our null hypothesis H naught is accepted. That means according to our assumption, mean of the population is 1600 hours. Hence we can accept this assumption. Now let us move on to second problem. A sample of 100 students is taken from a large population. The mean height of students in this sample is 160 centimeter. Can it be reasonably regarded that in the population the mean height is 165 centimeter, the standard deviation is 10 centimeter at 5% of significance? In this problem, we need to test the hypothesis for the given data at 5% level of significance. First consider the given data. First consider size of the sample, that is n is equal to 100, that is given. Sample of 100 students, that is size of the sample 100. Mean height of the students is also given, that is 160 centimeter, that we call it as mean sample, that is denoted by x bar, that is equal to 160 centimeter. Standard deviation of the population is given, that is 10 centimeter. In this problem we need to test the hypothesis for the population mean height mu equals 165 centimeter at 5% level of significance. Now, as usual, mean of the population, that is called H naught. We assume the null hypothesis H naught as mu is equal to 165 centimeter. Alternate hypothesis means H1, that is against to H naught, that is equal to mu not equal to 165 centimeter. As usual, calculate the standard normal variate by Z by using the standard formula, that is given by Z is equal to x bar minus mu divided by sigma by root n. Here x bar is mean of the sample, that is 160 centimeter, minus mu is mean of the population, that is 165. So sigma is standard deviation of population, that is 10. N is size of the sample, that is 100. Let us substitute all and simplify. We get the value for Z is equal to minus 5. So here our calculated value of Z is equal to minus 5. But already we know that at 5% level of significance, Z lies between minus 1.96 to plus 1.96. But here our calculated value of Z, that is minus 5, lies outside the interval. Hence here H naught is rejected. That means we need to reject our assumption. That implies mu is not equal to 165. According to our assumption, mu is equal to 165. That means mean height of the population is 165. But here our H naught is rejected. That means we need to reject the hypothesis. That means the population mean cannot be considered as 165. Okay, is it clear? I hope you understand this. Similarly, we can solve any number of problems. Okay, thank you.